Hi, good day seafarers. Today, we will talk about the different forces affecting our vessel, namely the wind, current, squat, shallow water. These forces are essential to be tackled about for us to have safer and smooth navigation. So the learning outcome. Working knowledge for the forces involved during maneuvering and sailing ship. The importance of this topic. The student will have a working knowledge of the forces involved during maneuvering the deep, and also the students will identify the effects of wind, current, squat, shallow water on ship handling while maintaining safety of navigation. I am Decadet Jeff Alichtigas, and me and my group mates will talk about these topics. I hope you'll learn something by the end of the video.
Force involved during maneuvering and sailing ships. Accepting that ship handling can be defined as using forces under control to manage forces not under control. This can be divided into the following three categories.
There are three types of forces. First is forces under direct control. Second is forces under indirect control. Third is forces not under control. So forces under direct control. These forces should be under direct control during ship handling. So examples are: first, ship's main engine; second, ship's propeller; third, ship's thruster; fourth, ship's rudder; fifth, ship's anchor; and sixth, ship's mooring. Professional ship's handlers should familiarize themselves with the performance and limitation of various ship's equipment used during the maneuvering.
Forces under indirect control. The most important forces said to be under indirect control are ship's inertia, other hydrodynamic factors such as bank effects, squat, interaction, and etc. The ship's inertia varies with different loading conditions, but the loading conditions can normally not be changed during the maneuver. To a certain extent, changing the speed of the vessel can control the hydrodynamic moment of inertia. Other hydrodynamic factors such as squat, bank effects can be avoided or minimized if they are known and understood. Forces not under control. The most important forces not under control are tide, wind, waves, current, and fouling. Although we cannot control these forces, we can do close observation by using available information, which can be used to minimize the effect of these forces.
Of winds. How does a headwind affect of the speed of a ship? Number 1, it will increase and decrease. Number 2, it will depend upon the relative direction of the wind. The ship would move and so in 1 hour with distance with respect. Number 2, wind force depends on windage, wind velocity, the angle between apparent wind and heading. Number 3, the center of wind pressure depends on the distribution of windage along the ship. The ship's handlers faces many problems, but there is none more frequently experienced and less understood than the effect of the wind.
The effects of current. Ocean currents play a very important role in ensuring the stability of the ship. The effect of currents therefore must also be considered when handling ships in waters. Effects of current are important especially when the ship is under the effect of onshore winds near offshore platforms while maneuvering in narrow channels, and open seas or inland waters or harbors. When the ship is in harbor or inland waters and the current is at constant strength and direction, the ship's handling becomes considerably easier. Currents affect ships during their voyages. A ship steaming against a current will need to use more fuel to maintain a required speed. A ship steaming with a current will save fuel and can proceed at increased speed. Effects of squat. The squat effect is the hydrodynamic phenomenon by which a vessel moving quickly through shallow water creates an area of lowered pressure that causes the ship to be closer to the seabed than would otherwise be expected. When a ship moves through the shallow water, some of the water displaced rushes under the vessel to rise again at the stern. This decreases the upward pressure on the hull, making the ship sink deeper in the water than normal and slowing the vessel.
Good day everyone, I am Cadet Tanker Jayton. So which part of the vessel is usually affected by squat? The resultant low pressure created by the obstruction is forward of the midship, and this vessel squat will occur more at the bow. This will result in trimming forward because of the squat on these vessels. The tendency of the bow to obstruct the water flow is related to the block coefficient of the vessel. Effects of shallow water. Shallow water affects the maneuverability of ships considerably. The limit water depth will change the pressure distribution around the vessel and lead to an increase of hydrodynamic forces.
Good day everyone, my name is Cadet Joseph, and the topic that I will going to report is the effect of shallow water. As the hull moves through shallow water, the area which it replaces is not so easily replaced by surroundings water, therefore leading to a state of partial vacuum as the propeller and rudder are still working. The vessel takes up longer to answer her helm, and response to engine movements becomes sluggish. At normal speed, it is found that steering becomes erratic when the depth of water is equal to or less than 1.5 times the deepest draught. A vessel drawing 8 m maximum draught will develop unsteady steering in water of deep 12 m or under. So,
for the effects of shallow water, so when a ship nearing an extremely shallow depth water, such as shoal, she is likely to take a sudden shift, first towards it, then violently away. This is called smelling the ground. The movements of a sluggish ship may suddenly become astonishingly lively.
I am Cadet Vinculado Jesere. Summary of shallow water effect on maneuvering include bow wave increases, maneuvering becomes sluggish, the engine load increases, the ship speed over water reduces, stopping distance and time increases, the turning circle increases to the great extent, rolling and pitching reduces, the ship may start to vibrate. So according to William Arthur Ward, the pessimist complains about the wind, the optimist expect it to change, the realist adjust the sail. So that's all for our presentation. Thank you.